Okay, hello everyone. I think I have introduced myself to pretty much everybody here. I am Nadine, and I am going to be talking about the perks of threat modeling, the threat modeling methods, actually. So before that, I would like to kind of give a brief, just talk about who am I, that hopefully will justify your time spent on listening to me. And well, without getting existentialist here, just to let you know that I am a information security specialist right now and a fintech called Tink here in Stockholm. And I am a CISP and also a Master in Science in Security and Mobile Computing. Since the beginning of my career, I have been in the security field. I just heard that there have been some exciting movements in the audience here between careers, but it's not my case. I have been all the time in security, which I have actually enjoyed. And it's been like 8 years almost in the same field. And I actually don't have any plans of moving anytime. So who knows what will happen next. But I have some experience with threat modeling, which I have been doing like for probably the last 3 years. Also experience with penetration testing, risk management, identity and access management, and just running programs around security and how to implement security for IT systems. So that's basically who I am. Now, the subject of interest here is like threat modeling. And I just want to kind of probably say something in addition to what Akka just said. So I think that threat modeling could be also think in a simpler way. It's just basically thinking about the bad things that could happen to a system, to an asset, or pretty much to anything. You can threat model anything that you want if you start thinking about the bad things. Um, but also I think that it's important to recognize what are like the benefits when it comes to systems. Like what do we get out of doing threat modeling? And one of the benefits is shifting security left. And what that means is that with threat modeling, you can actually start planning and implementing security during the design and the development phases of the system. So you don't have to actually wait till you have like a finalized product, because then it's actually more complicated to implement security then. Also, because with threat modeling, you can identify risks that will also help you to know where do you want to maybe focus your penetration tests efforts in terms of time and budget, which is also very beneficial. Then, because when you are doing threat modeling, you are thinking from different angles. So that means that after doing the threat modeling, you will have a broad view about your system, what are the threats in your system, and what are the weaknesses in your system. So that's also good to know it. And then we have that you don't actually need to be like a security specialist or a tech savvy to conduct a threat modeling. So it is good if you, as probably as a security person, can guide into the threat modeling and provide like this thinking from a security perspective. But then I think that it is also necessary to have the participation of people with other backgrounds, like somebody that is thinking about the business, somebody that is thinking about the technology, how to implement something, how to develop something, like the use cases, how is it going to be used. So it's not just like for tech persons or even security persons to conduct the threat modeling. So now about the methods. I'm going to be telling you about these 5 methods that I have used. I'm not going to be going into details about each of them, but I'm going to tell you what I have seen to be like the key benefits about each of them, and also like what is not so good about them. So to start with, able user stories. Basically, these are scenarios that we can think from the attacker perspective. So what are the things that an attacker will want to achieve with our system or with our assets? We can form these sentences that will say, as an attacker, I will want to. And then in this case, for example, is getting access to some data that you are not authorized to. But thinking as an attacker may not be like so easy for everybody. So then you can think about the other way around, like what you don't want the attackers to do to your system. And then you can also create your sentences and your scenarios based on that. What is good about this evil user stories? So it's ISAT identification. And because you, before like thinking about the bad things to happen, you need to think about what is it that you want to protect? What are your assets? What is important to you that you want to actually defend from attackers? So that's why you need to have a good list and inventory of your assets before actually starting with the evil user stories. Then it promotes stakeholder collaboration. So as I said, it's not only for like security or for like the technical person. So anybody that has an asset, and by asset, it's not just the hardware and the software, but also like maybe some process. So if it's an asset to you in the system, then you can participate and also provide some input into what are the bad things that could happen to your asset. Another benefit is that you don't need to have an architecture diagram for evil user stories. You can start with just like the conceptual idea of your solution of your system. And then from there, you can already list your assets and list the things that you don't want to happen to them. And that means that it can be used at that early stage of the design phase because you are just in the conceptual phase, the design phase. And it's also good, for example, if you want to check what are the threats for one specific feature, you can just go and create these scenarios. Now, not everything is good, of course. And what it's bad about, or not so good about, like the evil user stories, is that they can stay at a very high level if you just kind of have these scenarios and sentences, and that will be probably not as easy and straightforward to come up with security requirements when you actually want to implement something. And the other is that because of that, you may have to use it in combination with another method. So you cannot really rely only on it. It's just like a very good starting point. Or if you are, for example, for the features, then probably it will also be of good help, but it's still advisable to use it with other methods. Any questions that you may have? Okay, just feel free to interrupt me anytime. Okay, so now the attack trees. These are ways to identifying attack vectors, and you can use them like bottom up or top down. So if you are from bottom up, you think about your threat, and if you go up, you will think like, how could that realize? So what would be the possible causes to some threat? And that's how you will identify your vulnerabilities. But then if you go from top down, from the vulnerability or a weakness, you may think, okay, what could be the consequences of that? And you can go just down. So the benefits of that is that you will identify how the threats could realize. And this is actually pretty good because it kind of makes them more tangible. It's not just like you can think that some threat may happen, but you can actually see how it will happen. So it gives you like a good view of how like one thing can lead to another and to like something that could actually be really bad or catastrophic. And then you can identify on-point mitigations, and that's because if you go like higher up, you will find your main weaknesses or vulnerabilities, and for each of them, you can actually plan or think of what would be like a control or a mitigation for it. So that's how it can be like really on point just for one particular vulnerability. It also allows the broad threat discovery because there are like different paths to one threat, for example, and you can branch out as much as you want, probably as much as you have in your scope or even in your imagination. But you still kind of need to be conscious about it. And I'm going to tell you next why. But another good thing is that it can also be done during the design phase. Still, you don't need to have like anything already decided, just probably the conceptual idea. And then it's easy to map the threats to the risk. So as I told you, you can really see how one thing can lead to another. And if you go to the probably the bottom of your tree, then maybe you will see that that is an actual risk to you. So maybe from the vulnerability side, you don't really see like how bad it could be. But once you identify all the possible consequences to that, then you will see like how is that one risk to you. The bad things is that, as I said, if you really go broad with it, it can get really easy to be difficult to manage because you can really end up with a mess of a tree and with a lot of branches, and probably you won't have a lot of like control, and it would at some point lose sight in like how is it that actually things are happening there. And what I suggest is that you probably can split your threads as you identify, for example, something in the front end, something in the back end, probably per component. So you can try to split your attack threads into sections so that it becomes more manageable. And another thing that it's not so good is that you will actually need like some tools to kind of draw all the leaves of the tree and to make it also manageable. Because I guess the example here is probably just some like created from PowerPoint, but this is not good if you want to actually scale it. Next is STRIDE, which is very common, and it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So these 6 main threats are the ones that are covered by STRIDE, and it's basically thinking about how those things could realized in your system. What is good about this is that it's attack focused. So that means if you're concerned, it's really how an attacker will want to come after you and in which ways they could do it with this main threats, then this is a good way to go with it. It covers the most common threats. Those 6 ones will kind of be the most common ones. And that means that if you identify and implement controls for these 6 threats, you will probably end up with a good security posture for your system if you actually implemented the controls for that. What else? Then it also helps with the test case identification, because if you are thinking of the attacks for your system, then you also want to probably test that your system is actually robust to those attacks. So that will also give you the places or the elements that you want to test in your system. Then it's a very structured way of working because you are not actually moving far from those 6 threats. So whatever you want to analyze in your system, even if it's for users, for processors, for the data, for storage, whatever, you will still be only thinking about those 6 threats. Now, what it's not so good about it is that it's limited because it's only concerning these 6 threats. And if there are other threats for your system, you will probably overlook them. Of course, it will depend on the system if it's something else would actually make sense to analyze or not. And then it can be highly technical because you have to have a good understanding of what those threats are and how they could realize, because otherwise it may be challenging to actually identify if it's a threat for you and if you actually have like a way in how that threat could realize. Next is PASTA. So this stands for Process for Attack, Simulation, and Threat Analysis. This is a 6-step method in which you will first define the objective and also create the context for the risk and the threat analysis. What is good about this is that it's risk focused. So with the context that you are creating and the objectives, the end result will be those risks that are actually meaningful for your organization or your system. And then it can also help you prioritize the mitigations. So if you have identified that you have a high severity risk in certain area, maybe you want to put your efforts into like mitigating that. And then you can leave probably for later stages something that it's not that important to you. but based on the risks. Then it's comprehensive because with these 7 steps, you can actually try to link the business objectives to technical controls, and it provides a lot of input for the analysis. So you actually require to probably leverage other methods so that you can actually do the analysis and have something that it's actually meaningful for you. Yeah. And that's also good that it has defined deliverables. So each step will give you a deliverable, and that's good when you are like actually implementing and working on your mitigation strategy, because it can be kind of easy to forget why you have made a decision about what you are prioritizing or what you want to do first. But then if you have like this evidence that if you go back to the deliverables and check, okay, because it came all because of this, so then you can trace back about how you made those decisions and why it's actually making sense to go on with your strategy. It also promotes the collaboration from stakeholders, because it does require the participation from like business stakeholders, like the users, the developers, the architects. So everybody should be providing their input so that finally the business objectives are mapped into like technical and security requirements, and to kind of implement something that it's feasible and that it makes sense. What it's not so good about it is that because it's 7 steps, it can be lengthy. And also that means that it will take time and effort from everybody. So you actually need to plan ahead who are the participants. You need to clear probably their schedules for whatever time you think that this will take. It depends also on, for example, what is the objective and the scope that you want to go with it. So it does require also some planning to do it. But I think that because it's like very comprehensive, the output, it's something that it's really good. So if your system it's like kind of really big, I think it's good to go with this one. And then we have architecture reviews. Now, this is just looking at the architecture and going kind of inspecting all the different elements and seeing how some threats could realize for each of them, and identifying like the different components, maybe how data it's going from one to another and those things. So what is good about this is that it will give you an overview of all your components. And this is good because you will have them probably in the diagram, and you will see like, for example, what is in the front end. So if you have like a gateway, an API, and whatever, you will have an application, or what is in the back end, what are the different components. If there are like some systems that are interacting with your system, like how those interactions happen. So you will actually get to see the whole view. And that also helps you with the attack surface identification, because you can see like what are the interfaces that are exposed. Something that it's probably out of your control. Is that something that you can actually trust, or do you actually think that there is a threat between between the systems? So that's also one good aspect about it. Then it provides a thorough threat identification. And that means because you are looking at from the architecture perspective, then you also have like the technology, the data flows, the processes, so that you can actually get like different perspectives and different views into what are threats into your system. So if it's something about like the technology that you are using, if it's something about like one critical process, like how data is going from one element to another, how systems are authenticating each other, all that kind of stuff. It's something that you can actually see it when you do this review. It also helps you with the test case identification, because again, you have like this deeper look into your system. So then you can also see, okay, so this is my attack surface, and probably it makes sense that I will check something that is more exposed than other things, or something where I would see that probably is more likely that it will have a vulnerability, for example, I don't know, some operating system is more vulnerable than others. So those type of things you will actually see and you may want to test. And it's also good for complex systems because it really enables a good understanding of the system. So if the system is very complex, if you just take the time to actually look at the architecture and inspect it and look at all the different components, then you can really understand better your system. Now, what is not so good about them is that you need to have good quality diagrams. And this can be often challenging if you are not used to create your diagrams like from the beginning. Then if you just kind of launch instances, services without control, then at the end, you don't really know what you have and what you're dealing with. And at least having some diagrams gives you the idea, okay, I have this and this and this. But if you just don't create any diagrams, if you, for example, omit some systems that are interfacing your system, if you omit maybe the protocols that you are working with, if those things are not really in your diagrams, maybe you will miss some of the threats regarding like specific protocols and technologies. And well, that also means that it can be highly technical to understand an architecture. You kind of need to know about the technologies, need to understand like also the protocols that are used, need to understand like the different services, what does it mean to be in cloud or on premise. So those type of things you have to understand to actually think of the threats for that. Okay, so in conclusion, it's important to know what is it that you want to accomplish with threat modeling. Is it just that you want to look at a feature? Is it that you want to create a threat model like from the beginning of your system and then probably build up from there? Is it because you really want to provide security for your system? Is it just because you want to be compliant with something? So it's whatever your reasons are, you have to have that clear. Another thing important is to promote openness. So in the threat modeling, I have experience normally running them as workshops, and all the stakeholders take part in them. And it's important to kind of keep the openness in the conversation there, because it's not an audit. It's not just looking at what is wrong with your system. It's thinking about what the bad things that are really like threats for your system, and how can you actually improve the security or prevent those threats from occurring. So if you think that after all it's just for the benefit of your system or actually providing security, and not that you will be looked at because maybe you forgot or you didn't think that something was a weakness and it turned out to be. So it's really good to promote the openness among the team so that everybody is really forward about saying like, I think that this is really a threat and I think that this is how it could happen. Because if you identify that, then you can actually plan a control to mitigate that. It's also important to know your resources. As I mentioned, some can take time, maybe some tools, and also the time from the team. So you need to know who you will have to be there for your workshops, for the modeling, and also like what are the time constraints that you may have, or also in terms of budget. After all, it really depends on what you want, but there are like different methods. I just presented 5, but there are others also available to you. So it's just about choosing the right one for whatever your needs are. Okay. So yeah, if you want to reach out to me, that's my LinkedIn. So you can find me there. Thank you.